Computer programs are a list of instructions to the microprocessor. Each instruction is simply a series of numbers that are recognized by the processor as having some specific meaning. Let's look at a simple example. This simple program asks the user for two numbers, adds them, and displays the result on the screen. When it's done, it starts over. Of course, our example is written in English. A microprocessor only understands machine language. So what is machine language? Machine language varies depending on the make and model of the microprocessor, but all machine languages have a similar structure. Here's a fictitious example of a simple machine language. The microprocessor understands 6 different instructions. Do nothing, get a number from the keyboard, display a number on the screen, add 2 numbers, go to a different step in the program, and go to a different step, but only if the result of the last addition was 0. Each instruction has a code and a mnemonic. The code is what the microprocessor actually understands. The mnemonic is used by the programmer instead of the code, as it's easier to remember than a number. Let's take another look at our example program. How could we write this so our fictional microprocessor can understand it? The answer is to replace each of the steps with the appropriate instruction code. Let's look at the instructions one by one. Get a number from the keyboard and store it in a variable called x. In our fictional machine language, the read instruction handles this perfectly. So we record the code in our program. Step 2 is much the same. The only difference is the variable. And now our program adds the 2 numbers. In our machine language, the add instruction handles this step. So we again record the code in our program. Step 4 is to print the result to the screen. In our machine language, this is well handled by the write instruction. So again, we record the code in our program. Finally, the last step is to go back to step 1 and start over again. In other words, our example program will run forever. In our fictional machine language, the jump instruction is the one we need. So we record the appropriate code in our program. If you're awake, you may have noticed something interesting. While we were converting our program to machine language, we didn't specify the variables x, y, and z. And we didn't tell the microprocessor where to jump to for the jump instruction. In reality, this information would be encoded as a series of numbers immediately following the relevant code in our program. For the sake of simplicity, those numbers were not included in our example. Believe it or not, this is actually part of a real computer program. The ones and zeros are written in a number system called hexadecimal to avoid causing the reader to go completely insane with all the ones and zeros. Even still, it doesn't make light reading. Even with the mnemonics, programming in machine language is no easy task. So computer scientists invented programming languages. Programming languages make the programmer's life much easier. The programmer can write instructions in a language more like English, using words and variable names. A special computer program called a compiler is then used to translate the programming language code into machine language that the computer can understand. A library is a collection of small programs that the programmer can reuse so they don't have to reinvent the wheel every time they begin a new project. For example, the C programming language includes a library of functions for putting text on the screen, accepting keyboard input from the user, and performing complex math operations such as the square root function. By using this library, the programmer doesn't have to figure out how to do each of these things every time they write a program. Operating systems include Mac OS X, Linux, and Windows. Operating systems are comprised of special programs and libraries that make the computer easier to use and easier to program. Modern operating systems allow users to interact by using a mouse, keyboard, and screen, a touchscreen, or even speech. Hopefully, computers are a little less of a mystery to you now than they were before you started watching. For more information, please visit the program website at www.joshuahawcroft.com/howcomputerswork. I hope you've enjoyed the series.